Heights of 10-year-old children, regardless of sex, closely follow a normal distribution with mean 55.8 inches and standard deviation of 5 inches. Round answers to 4 decimal places. What is the probability that a randomly chosen 10-year-old child is less than 52.5 inches? Now, the first thing that I recognize here is I'm working with a distribution that is normal or bell-shaped. So it's probably a good idea to start off sketching a bell-shaped distribution. The pertinent information for any normal distribution is its mean of the population and standard deviation. So let's label those. Mean is always located right in the center. And I'm trying to find a probability. So what is the probability that a randomly chosen 10-year-old is less than 52.5 inches? So 52.5 is just slightly lower than the mean. And if I want less than 52.5, then I would shade to the left of that. So the solution that I'm looking for is an area under the curve, because the question asks for a probability. The function normal CDF in the calculator comes up with probabilities based off of normal distributions for me. It just requires 4 inputs. The first 2 inputs are the lower bound of your shaded region and the upper bound of your shaded region. The lower bound in this case is negative infinity, so we'll just use something small. And negative E99 is a great thing to use because it's extremely small relative to the rest of the data, and it effectively just means 1 times 10 to the 99th power. And 52.5 is the upper bound of that shaded region. And then the last 2 inputs are the mean of the distribution and the standard deviation. Now I'll get the calculator out. So normal CDF. Make sure you hit negative and not the minus. Then E you get by doing second and comma. Then 99, 52.5, 55.8, and 5. So 0.2546. Now, some of you may have seen a menu come up when you try to do normal CDF. And some of the later model calculators do that. They give you a menu to work with and allow you to type in the inputs to the normal CDF function in the same way, but they give you reminders as to what each input should be. So of course the lower and upper bounds, and then the mean and the standard deviation. It doesn't make the calculator work in any different way, because after you hit paste, it just puts on the home screen that information right into normal CDF and then runs the function for you. What is the probability that a randomly chosen 10-year-old is more than 60 inches? Now, if we are looking for a probability again, but this time, probability that a child is more than 60 inches tall. So nothing much changes, just the shaded region. So the center is still 55.8, so 60 is somewhere over this way, and we're shading to the right because we want more than 60. So we will use normal CDF. And the only thing that will change are the first 2 boundaries. So the very first boundary of the shaded region is 60, that's my lower bound. And then positive infinity is the upper bound, but I will write that in as e to the 99th. And then the mean is 55.8, and standard deviation is still 5. So normal CDF, and just enter your inputs accordingly. And we come up with 0.2005. What proportion of 10-year-old children are between 52 and 61 inches tall? A proportion is just another way of asking for a percentage, which we interpret as a probability. And this is between two values. To do a between probability, you don't really need to sketch it out, but I'll show you here. Your sketch generally is just to help you identify what the lower bound of your shaded region and the upper bound of your shaded region are. But when you're doing a between probability, the upper bound and lower bound are pretty easy to identify. So normal CDF, lower bound 52, upper bound 60.1, and 55.8 and 5. So we'll use the calculator to get our probability. And we come up with 0.5815. "95% of all 10-year-old children are less than blank inches." Okay, so to get started, let's begin by drawing a normal distribution. We know our mean is 55.8 inches and the standard deviation is 5 inches. 55.8 is located right in the center. Since that's measured in inches, that means my entire scale along the x-axis is measured in inches. That's the unit of measure. And what I'm looking for here is 95% of all 10-year-old children are less than some number of inches. So it's an x value along the x-axis. So 95%, that's a very big proportion. And less than, that means shading to the left of a value. So what I'm going to do is I'm going to put some value here and shade to the left of it in such a way that I think that this is approximately 95% of the area's distribution, or the distribution's area. Sorry about that. Now, what I'm looking for is a value x, which is measured in inches. And so in order to find a value that's relative to the units of measure of the mean and standard deviation, that's where I use inverse norm. So x equals inverse norm. And it takes 3 inputs. The inputs it takes are the area to the left of the missing value. So the value I'm looking for, x, has 95% of the area under the curve to the left of it. And then the last 2 inputs are still the mean and the standard deviation. And we'll use the calculator to find the result. So 0.95, 55.8, and 5. Then the mean is accurate to the first decimal, so I'll just round to the first decimal, which in this case is 64.0, which would be fine to put as 64. But just follow any rounding rules that you're given.